Hi guys. So I'm going to do some problems, or all the problems from PP4.2. Let's get started. So the first three sets of problems, I said, hey, divide these. And you can use any method, well, the best method. And as you can see, the divisor on this is a linear. It's a linear and has a coefficient of 1, which tells me, hey, I can use synthetic division. So this actually says x equals 5. So I can set up 5. And then let's go ahead and set up our dividend, making sure that every term is represented with a coefficient. 15, negative 25. Bring down the 3. It's 15. Negative 2. Negative 10. 5. 25. We have a remainder of 0. So when you divide x to the third with x, you end up with x to the second. So there you go. X plus 5. So your quotient is x squared minus 2x plus 5. And that's your final answer. Good job, guys. Number 2. Okay, notice, check out that divisor. Okay, so it has a coefficient of 2, which is doable as long as the leading degree, or the degree, is a linear, but it's a quadratic. So that tells us that no, we can't use synthetic division, that we have to use long division. Okay, setting up my dividend, making sure every term is represented. 3, 2, 1, 0. There we go. There we go. So first of all, we divide the first two terms. Okay, and you end up with 3x. And then you multiply the quotient, the part of the quotient, 3. We're going to multiply part of that quotient through the divisor just like that. And we get 6x cubed plus 3x. There we go. There we go. Uh-oh, 3x. You can't add that to x squared. Means we have to find the place that we have to add it to. Right there. Now, need my yellow. We're going to change the signs. Minus and minus. And then we end up with a 0. You want to end up with a 0 as your first term. Minus 2x. Bring it down, bring it down. And you can bring down all of the terms, actually, if you wanted to. Okay, now let's go back and divide the first terms. 2x squared equals 5. It's going to be a plus 5. And then we're going to take that 5 and we're going to multiply it through the divisor. So 10x squared plus 5. 10x squared. Find the plus 5 right there. And then we have a minus and a minus. So we have a 0 minus 2x. And that's a plus 8 minus 5. So that's a plus 3. So here's my remainder, because this is x to the 1, which is smaller than the x to the second. Okay, and the way that we write it, you can add a plus there, is in a fraction form with the remainder as your numerator and the divisor as your denominator. So you end up with 3x plus 5 plus minus 2x plus 3 over 2x squared plus 1. Good job, guys. Next one. Okay. So once again, look at the divisor. Hey, it's a linear, has a coefficient of 1. So I can use synthetic division, making sure that all of my terms are represented. -1, 26. Bring down the 6, 18, 21. Okay, we have to multiply a little bit, right? 3, 6, 62. And wait a second. Oh, I made a mistake. I don't know where that 7, -1, and 26. I have no idea where that 3 came from. Bring down the 6, 18, and then 25. 25 times 3, 15, 675. And then the 74 is 12. So you should be 222. So we end up with 842. And since we divided x to the third with x, we're going to get an x squared. So we have a 6x squared plus 25, x plus 74 plus 248 over x minus 3. Okay. Next problem. Okay, so it says find the remainder when f of x is divided by g of x. Okay. And it gives you the dividend and the divisor. So we can actually use synthetic division or long division on this, or we can use the remainder theorem. The remainder theorem states that that divisor right there, x plus 2, and you set it equal to 0 and solve for x. Okay, when I take that number right there and I put it as an input of the dividend right here, okay, the output is going to be the remainder. So all I have to do is -2 equals -2 cubed minus 5, -2 squared minus 7, -2 plus 4. That's going to give me a -8. And then minus 5 times 4 and a plus 14 plus 4. That is going to be a -8 minus 20, and that's plus 18. That is going to be -28 plus 18, which gives me a -10 as my output. And so the remainder of this is the output, so that is going to be -10. Good job, guys. Next problem, once again, x minus 1 equals 0, x equals 1. Let's go ahead and put this as the input. Of the divisor. So we have, ones are easy to work with, right? 2 plus 3 minus 1 plus 3. It's going to give me a 5 minus 1 plus 3. That's a 4, 7. F of 1 equals 7. And you can check these by doing synthetic division on them if you want to. We have a 0 for the 5. We have a 6, 5, 4, 3, and then 2, and then 1 doesn't have 1, and a 0. Okay, 2, 2, and that's 2, and that's a 1 and a 2 and a 5. Add those two. 5, 5, 5, 4, 4, 4, 4, and a 7. That's your remainder. Good job, guys. So we're going to use the Descartes rule of signs to determine how many possible zeros there are. We have to look for sign changes. For this right here, we're looking for positive zeros. Positive 0, possible positive zeros. We have a sign change here. That's 1. We have a sign change here. That's 2. We have a sign change here, that's 3. We have a sign change here, that's 4. We have a sign change here, that's 5. So 5, decrease that by 2. That's going to be a 3. Decrease that by 2, that is going to be a 1. So possible positive zeros are 5, 3, or 1. Now I'm going to take that P and I'm going to input a negative X negative x to the third minus negative x to the second plus 8 negative x minus 8. That's going to give me negative x to the fifth. That's going to be a minus 3x to the fourth. That is going to be a minus 2x to the third. That's going to be a bit minus x. It's going to be a minus 8x and a minus 8. And if we look for the sign changes, no sign changes here, no sign changes here, no sign changes here, no sign changes here, and no sign changes here. So for the negative 0, you're going to have possibility of 0. Okay? Good job. Next one. For the positive zeros, we have a sign change here from a positive to a negative. No sign change here. And then one sign change here, so that's 2. 2, reduce the 2 by 2. So you get either 2 or 0 possible positive zeros. Now let's do P, negative X. Ooh, that lavender color comes out nice. X cubed minus negative X squared minus 5 negative X plus 1. Negative 5x cubed minus x squared plus 5x plus 1. Let's look at the sign changes. No sign change here. We have one sign change there. So for the negative 0, it's just 1. I mean, if we reduce that by 2, that's going to be a negative number. We can't have a negative count of something. Got it? Got it? Good job, guys. Last one. Whoa. That's a long polynomial. Okay, so let's look for the possible positive zeros. We have one sign change here. Okay, so that's one sign change right there. And then here we have the second sign change from negative to positive. It's a third sign change, fourth sign change, fifth sign change, sixth sign change. So positive 0, 6, reduce that by 2, that's 4. Reduce that by 2, 2, or 0. Now let's do the negative. Possible negative zeros. We have P of negative x equals negative x to the 8th minus negative x to the 5th plus negative x to the 4th. Whoops. Uh-oh. going on with my computer?
You broke it.
Be quiet. Negative x to the third plus negative x to the second minus negative x plus 1. Okay. So x to the 8th plus x to the 5th plus x to the 4th plus x to the 3rd plus x squared plus x plus 1. Look at the sign change. No sign change here, no sign change here, no sign change here, no sign change here, no sign change here. Ooh, that was fun. 0 negative, possible negative zeros. Good job, good job. Okay. Here's a polynomial function. State all the possible rational roots of p to the x. Now, we have to use p over q. Where is it q over p? Is it p over q or q over p, Lachlan?
For what?
Polynomials. Possible polynomials.
P over q or q over p?
Uh-huh.
I think it's p over q.
P over q. Okay, so
I think
constant over quotient. Or constant over the coefficient. Okay, so let's go ahead and figure out all of the possible factors of p plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Q is plus or minus 1, plus or minus 2. Now, all the possible, let's go ahead and make the denominator 1. So that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. If we make a denominator of 2, that's going to be plus or minus 1/2. 2 over 2 is just 1, which is already listed, plus or minus 3 over 2. 6 over 2 is 3, which is also listed. So there we go. Okay, next, find all the roots if x minus 1 is one of the roots. So this one gives us one of the roots. So I can take that 2. I can use synthetic division, 1, negative 13, and 6. Bring down the 2, 4, 5, 10, negative 3, negative 6, 0. That's going to be x to the second plus x minus that right there. That's a quadratic. So once we get down to the level of quadratic, we could just set it equal to 0. We can figure out the discriminant, see if that's factorable. It's going to be 25 minus 4 times 2 times negative 3, 25 plus 8 times 3, that's 49. Yes, it is factorable. So I'm going to do a 2x and an x. We have a plus 3 and a minus 1. So that's plus 6 minus 1. Yay. 2x minus 1 equals 0. X plus 3 equals 0. Find all the roots, right? X equals 1/2. X equals negative 3. So the roots are x equals 1/2, negative 3. And do not forget about this 2. Yay! Good job, guys. Okay, next problem. Here's a polynomial. It says state all the possible roots. So we're going to do p over q again. This is p, that's q. Okay, so q is plus or minus 1, so we just have to worry about p, factors of p. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Okay, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Okay, so if I use Descartes' rule of signs, I can see one change here, two changes. So we have a plus. For it to be a plus, it's either 2 or 0. If I put a negative, that's going to be a plus x to the 4th, and then a negative in here is going to give me a plus 5x cubed, and then over here it's not going to change it, and that's going to change it, and that's going to remain the same because it's constant. This only has 1. Okay, so my best bet is to focus on the positive zeros. So let's go ahead and let's do 1. Just to see how it works. 1, -5, -5, 23, and 10. 1, 1, -4, -4, -9, -9, and that's going to be a 14. That's not going to work. Okay, so let's go ahead and erase that. Let's try a 2. 1, 2, -3, -6, -11, -22, 1, and then 2. Nope, still doesn't. Okay, let's try 5. 1, and then 5, 0, and then 0, -5, -25, and then it's a -2, -10. Voila! So that's reduced it down to a cube. This is x to the second, x minus 2. Okay, just like that. But we have to continue. Okay, we have to continue. And now that we know that there is a positive root right here, if we know that there's a positive root there, okay, then one positive root, then we know that it's definitely not going to be 0. So there's another positive root there. I'm going to try a 10. 1, 10, 10. Oh, that's too big. That is way too big. But we tried all the positives, didn't we? 1. Let's try 1 again. 1. Maybe I did something wrong. 1. 1. -4. -4. Nope. So we tried all of them, but maybe it has a multiplicity. Let's try 5 again. 1, 5, 5, 25. No, that's still going to be too big. Okay, so let's go ahead and try some negatives. Okay, I'm going to try -1. We have a 1. -1. -1, -1, -4. Nope. Let's try -2. 1, -2, -2, 4, -1, 2. That worked. Okay, so we end up with x squared minus 2x minus 1. Set that equal to 0. Minus 2x minus 1. Set that equal to 0. We can just try b squared minus 4ac. So 1 squared minus 4 times, whoops, Nope. We have negative 2 squared minus 4 times 1 times negative 1. 4 plus 4, which is 8. Nope, it's not going to be factorable, so I'm going to go ahead and use the quadratic formula. Equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's going to be a 2 plus or minus square root 4 minus 4 times 1 times negative 1 over 2 times 1. So 2 plus or minus square root, and we had 8 in there, right? 4 plus 4 is 8. 2. We were actually just looking for the real roots, but I mean, if you want to take it further and actually find, so 8 is made up of 8. 8 is made up of a 2 and a 4. So it's going to be 2 to the square root of 2 over 2. So that's going to be 1 plus or minus square root of 2. So once again, I was wanting just reals for this. So your answer should have been x equals 5 and negative 2. But if you're looking for all of the real zeros or all zeros, then the other one would be square root of 2. Okay? Good job. Next. State all the zeros or roots of piece of x and write in factored form. Okay? So let's do p over q, which is still going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those are the factors of 10. Factors of 1 is going to be just the denominator, which is plus or minus 1. So I'm going to set this up. 1. Let's try 1. I want a different color. 1. And we have a 1, 2, negative 13, and 10. 1, 2, 1, 3, 3, negative 10. That's going to be negative 10, 0. Found it on the first try. Plus 3x minus 10 equal to 0. Try my discriminant, see if it's factorable. 9 minus 4 times 1 times negative 10. That is definitely not going to be factorable. Okay. And so this was just about real zeros, so you could put it as x. And remember, if this is a factor, I have to rewrite it. I mean, if it's a 0, then I have to rewrite it in its factored form. Plus 3x minus 10. And this is what I wanted. And the zeros would be x equals 1. That's the only real 0 that you have. I mean, you could use the quadratic formula. X equals negative 3 plus or minus the square root. 9 minus 4 times 1 times negative 10 over 2. Negative 3 plus or minus square root. It's 9. And that's plus 40. Oh, it was actually factorable. Why did I not say 9 plus 40? 49. Sorry. So x plus x minus, is it 5? Oh yeah, 5 and 2. That's completely wrong right there. So x equals negative 5, x equals 2. So negative 5 and 2, factored form, x plus 5 and x minus 2. Okay? Good job, guys. Let's see the next one. Okay, This one we have 9 over 4. So let's go ahead and find all the factors of 9 plus or minus 3 plus or minus 9 plus or minus 1 plus or minus 2. So P over Q is going to be, you can have a denominator 1, so plus or minus 1, plus or minus 3, plus or minus 9. You have plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Okay, let's go ahead and set it up. Where's that pretty lavender color? Yeah. Let's go ahead and set it up. We had a 4 for x to the 4th. X to the 3rd is going to be a 0. X to the 2nd is going to be negative 37. X is 0. And then x to the 0 is going to be 9. Okay. I'm going to try a 1, 4. 4, that's 4. And then we have a 4, and then a negative 33. That is definitely not going to work. Okay, let's try a 3, 4, 12, 12. 12 times 3 is 6, 36. We have a negative 1, negative 3, negative 3, negative 3, negative 9. Yep, works. We've reduced it down to x to the 3rd. Okay, let's try another one. Let's try, 1 didn't work. So positive 1 is never going to work. Okay, so we've taken out the positive 1. I'll keep on writing plus or minus. Plus 1 does not work. We could try 9. 9, 4, 36. No, that's going to be too big. Okay. Let's try negative 1. 4, negative 4, 8, negative 8, negative 9. Erase that, erase that, erase that. Let's see. I'm gonna try maybe 1/2. 4, half of 1/2 is 2. 14, 7, 6, 3. Ha! Worked! So this is x to the 2nd plus x plus 6. 4x to the 2nd plus 14x plus 6 equals 0. Okay. Just want to make sure. Okay, I'm going to use b squared minus 4ac. That's 14. By the way, couldn't I reduce all of these by 2? Yeah, 2x squared plus 7x plus 3 equals 0. Okay, so that's 14. Nope. 49. 49 minus 4 times 2 times 3. 49 minus 8 times 3 is 24. 24. And 49 minus 24 is 25. Yes, this is factorable. 25 is a perfect square. So we have a 2x plus and an x plus. We have a 3 and a 1. That's 6, 7. So x equals negative 1/2. X equals negative 3. So my zeros are x equals 3, 1/2, negative 1/2, and negative 3. Now to rewrite that, x minus 3 and x plus 3. And then we have to see x minus 1/2 and then x plus 1/2. But we can't write it like that. We can bring that 2 to the front and this 2 to the front. And this ends up becoming 2x minus 1. And this ends up becoming 2x plus 1. 2x minus 1 and 2x plus 1. Okay? Good job. Number 15. Let's see. Making sure that I didn't skip one. So we have 4/2. And so that's plus or minus 1, plus or minus 2, plus or minus 4. That's plus or minus 1, plus or minus 2. So P/Q is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/2, 1, 2. It doesn't work. So set it up. 2, 7, 4, -4. I'll try my 1, 2, 2, 9, 9. Nope, I don't think that's going to work. Let's try -1. -1, 2, -2, 5, -5, -1. Nope, that's not going to work. Okay, let's try it. 2, 2, 4, 11. Nope, I don't think that's going to work. Let's try -2, 2, -4, 3, -6, -2, 4, 0. Brought that down to a quadratic. 2x squared plus 3x minus 2 equals 0. Let's look at the discriminant. The 9 minus 4 times 2 times -2. So 9 plus 8, 8, 16. 9 plus is 25. It factors. 0, 2x, x. We want it to be a positive here and negative here probably. I have a 2 and a 1, 4, and a -1. Okay, so we have 2x minus 1 equals 0, x equals 1/2, and x equals -2. So the zeros of this, x equals -2, -2 again, and 1/2. So the way you would write this is x plus 2 squared and 2x minus 1. We have number 16. And just making sure this is all I gave you for this homework. Number 16. So it is going to be a 16/6 plus or minus 1, plus or minus 2. 3 doesn't work. Plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Wow, we're going to have some fun with this, huh? Okay, so let's go ahead and set it up. We have a 6, -23, -13, 32, and 16. Try 1, 6, 6, -23. That's going to be a -17, -17, plus going to be a negative 30. Negative 30. 2. 2. Nope, not going to work. Okay. Next one, 2. 6, 12 is negative 11, negative 22, negative 35. I think that's going to maybe possibly be too big. It's a negative 70. That's a minus 38. It's going to be too big. Oh, I forgot to look at the possibilities. Doing this too quickly. So that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. One with a denominator of 1/2. 2. 1. That's going to be a 2. That's going to be a 2. 8. That's going to be a 4. 16 divided. That's already. So plus or minus 1/3 with a denominator of that. Plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, and then plus or minus 16/3 with a denominator of 6, 1/6, plus or minus 1/3 is already encapsulated, 2/3 is already there, 8 4/3 are already there, 16 divided by 6, it's 8/3 is already there. So those are all the ones. Okay. Let's try 2. We tried 2. Forgot. Did we try 2? Let's try negative 1. 6, negative 6, 23 plus 13, negative 36. What am I? 23 plus 6, 29, negative 29. 29 minus 13 is 16, negative 16. 32 minus 16 is 16, and then negative 16. There we go. So this was x to the 4th. This is x to the 3rd. Let's see what else works. I think we tried 1 and 2. It didn't work. Let's try negative 2. No, 6, negative 12, 29 plus 12. That's going to be a large number. Multiply that by 2. That's going to be even larger number. I don't want to try that one. Let's try 4. I don't think we've tried 4. 6, negative 24. No, positive 24. It's negative 5. Negative 20. And then negative 4. Negative 16. 0. Okay, now we've reduced it down to x to the 2nd, x. So 6x squared minus 5x minus 4 equals 0. B squared minus 4ac. 25 minus 4 times 6 times negative 4. 25 plus 4 times 6 times 4 is going to be 96. 96 plus 25 is 121. So that is factorable. 0. So we have, let's try 3x and 2x. And then a negative, a positive here and a negative here. I want to do a 2 and a 4. 412. 412. Maybe a 4 here and 1 here. That's going to be 8. Negative 8. And a positive 3. Is that right? 4 times 2 is 12. I think that's right. Okay, so our factors are going to be 3x minus 4 and 2x plus 1. So our roots are, so the roots are going to be negative 1, 4, 4 over 3, and negative 1/2. And our factors are x plus 1, x minus 4, 3x minus 4, and 2x plus 1. Okay? I think that's it. Good job, guys.